Hi and welcome to this screencast. Today I'm going to try and attempt to solve question 18 around momentum. This is a complex momentum equation where we have interactions going on, and you'll notice that in the question we have two objects that are initially moving together. So the question does ask us to refer to figure earlier on in the chapter, but that doesn't really matter. We can still solve it without even looking at it. So here we are with our variables identified for the situation. We have our mass 1 and mass 2 for each of our individuals. We have a combined initial velocity represented by u, and that is 2 meters per second to the right. The direction is very important. We're assigning the right direction to be positive, so we'll leave it as a positive 2. And we're informed that the final velocity of object 2 is 4 meters per second also to the right, so we will also leave that as a positive 2. Now it's important to note the names of objects 1 and 2. So our mass 1 was Renfrew, indicated by an R, and our object 2 was Prunella. I'll just assign a P for that. Now that's not too important with our equation and our rearrangements, but it's important for us to understand which object is mass 1 and which person is mass 2. Now there's one piece of information that they are asking us to find, and that is the velocity of object 1, which does happen to be Renfrew. So that's why the name is important. So I'll just identify our framework first. So we do need to use our conservation of momentum knowledge, where the initial momentum must be equal to the final momentum of the situation. Before I get started into that, it is very useful to draw a diagram first. So if I draw an initial situation and a diagram for that, we've identified that object 1 is slightly larger than object 2. I'll signify that with just two different sized boxes. I'll just label them 1 and 2. But we do know they have a combined or similar initial velocity, or I should say the same initial velocity as they're traveling together at the same velocity in the right hand direction. So the final situation, however, there's only so much information we know. They are saying that object 2, who is Prunella, pushes back onto object 1, who is Renfrew. So we can now assume that they are now separated after the collision or after the situation. We do know that Prunella has a velocity in the right hand direction. What we don't know and what we want to find is the magnitude and direction of the final velocity of object 1, who is Renfrew. So we'll get started with our work. Notice I'm working down the page and I have my diagram and all our variables set out nice and clearly. This is the best possible way for us to understand what's coming next, and it just helps to organize and structure our work. So to get started, I'll start with our usual formula. So I've identified object 1 momentum, and momentum being mass times velocity. We've used lowercase u for our initial velocity. We're adding that to the second object. So likewise with the final momentum, we have momentum of object 1 in addition to the final momentum of object 2. Now for this particular context, we have objects 1 and 2 combined at the start. So we must combine these initial momentums, u1 and u2, to just be u. And then we can factorize to make our equation even simpler. So I'll show you what the next step will look like just for the left hand side. And then to factorize, we take our common factor outside the brackets being initial velocity. Since our right hand side didn't change for this line here, I'm not going to do anything. I'll just add it in for our third line. So we have our equation. We have all of these variables except for one very important one that we would like to find, and that is what we're solving for. We want to try and find the magnitude and direction of velocity 1, who is the Renfrew's velocity. So just substituting all our known values now. So we're left with this. Again, we do not know velocity 1, so we can't identify that just yet. By solving on the left-hand side and expanding that out, we do end up with 250. We're left with 75 multiplied by our final velocity of object 1, and we do get that adding to 200. Now I'm now going to subtract 200 from either side, and we now have ourselves a basic two-step equation. It might be a basic equation, but the context itself is quite complex, and that's what we need to try and understand. So we're left with quite a simple formula now, where I'll divide both sides by 75, and that will therefore give me the velocity of object 1, who is Renfrew, to be approximately 0.67 meters per second. Now back to this direction. Velocity is a vector, so we must have direction. We have a positive value that's spat out of this calculator, so therefore we can assume it's in the right hand direction. We can assume that because we already assigned the right hand direction to be positive as we put it into our equation. So there we have it. We now have the final velocity and direction of object 1 after this impact.